My name is Sigal Shaked, and I am also a PhD student at the Department of Information Systems Engineering at Ben-Gurion University. And I'm going to tell you a little bit about using generative adversarial networks, or GANs, as they are often called, for text generation. Let's just start with why do I generate text, because people often look at me strange when I say that I generate stuff. So I will quote a wise physicist that once said, "What I cannot create, I do not understand." And this is my point. Because when you want to generate text, you need to teach the machine to understand what's going on, how the text works. And teaching a machine to understand is quite a challenge. So it's supposed to extract some kind of a language model out of the text, and then it can do many things, including generation of another text. And this is one point. The other point is, I think, a motivating point for me. The text is just one example of a sequence. There are many more interesting sequences out there, like genome data, neuron activities in our brain, stocks data, GPS trajectories, medical records, as you heard before, that store many physical reactions ordered by time sequence. So if we score this challenge in text, which is the easier case, because in text we understand the words, which are the basic components of the language, then we can do many more other things for other domains. Okay, so this is one part of the question, why do I generate text? The other part is, why do I use GANs? So in case you didn't hear before this buzz called GAN, let me point you to Jan LeCun, the director of Facebook AI. And when it says that GANs is the most interesting idea of machine learning in the last decade, you don't really argue, just go with the crowd and try it yourself. And this is what I did. It's not just this. Actually, it's also become a state-of-the-art technique for image generation, our similar task in the neighboring domain. So as you can see here, all these images were successfully generated using a GAN architecture. We are not quite there for text generation. We didn't see it such wonderful results, but we are working on it. A lot of efforts are made, including this current study that I'm showing you. So if you are not familiar with the GAN, this is a good opportunity to understand how it works. It's actually a game between two networks, neural networks. The first player is called the generator, and it takes some input noise and turns it into a real sample, or something that's supposed to look like the real sample, to come from the same distribution of the real sample. And the other player is called the discriminator, and it accepts as input both real data and generated data, and it's supposed to distinguish between the both. The generator tries to confuse the discriminator and maximize its loss, and the discriminator tries to minimize the loss. And it's kind of a minimax game between the two. At the end of each iteration, the discriminator propagates the loss into the generator, so it will fix itself and be wiser. And I guess this is the main obstacle when dealing with text, because as opposed to image, where everything is very differential and you can easily propagate the loss into each bit of the image, in text we are talking about something that is non-differential, usually imitated with a softmax output function in the output layer that's supposed to point at the right word out of the vocabulary. And this is a non-differential function, and therefore this doesn't propagate so well when trying to fit GANs to texts. So what I suggest here, after trying a lot of other things and getting a bit desperate, because I saw all the things the literature warned me I would see, like exploding gradients or the same generated result over and over again. And I had 1 week to submit a presentation and no results yet. So I said to myself, OK, it works for images. Let's just turn the text into an image, and then it might work. So this is what I did. I'm suggesting a framework because I can use whatever architecture worked well for image generation and just borrow it for text generation. As you can see here, I have to do the conversion from text to image-like format, and from the image-like format of the output, the generated output, back to text. So how do I do these conversions? I actually use the pre-trained word embedding model. There are many available pre-trained models out there based on Twitter, based on Facebook, based on Wikipedia is the one I used. And you can easily take your vocabulary and map it into an existing word vector or pre-trained one. And what you see is here is this conversion for each word. It is mapped into a continuous space with, in my case, 100 dimensions. For 20 words, we get a matrix, which is kind of an image-like format, as I like to call it. And in the other direction, I will also take each generated row and turn it into, map it into the nearest word vector in order to convert it back to text. Let's see some initial results. I have examined this framework on 3 repositories of various writing styles. The first is Britney Spears songs, the second was Donald Trump's tweets, and the third was Obama's tweets. And as you can see here, let's look at the blue score, which is the best we have today for evaluating generated text or translated text. It is based on the idea of comparing n-grams between 1 gram to 4 grams. And it's far from perfect, but this is the best we have today. So I generated 200 sentences for each of these models. Each repository had its own model. And if we look, for example, at Obama's model, or generated text, we can see quite a high blue score. And we also can see many reliable components within, like put proposals or globalization change ways. The short parts are OK, but the whole sentence is still corrupted. I guess this is because I took the framework, the W-GAN, which is another version of a GAN with the Wasserstein loss function. I used it as is from the image domain, and I didn't add any changes. So this is the next phase to use some larger grid size for the convolution layer, to add some pooling layers that will try to extract some features of the entire content. So if you have any tips or tricks for me, suggestions for using something that really is fitted for text domain, like a convolution that goes over the entire sentence instead of just 5 words at a time, like I did using the current W-GAN setting, I will be happy to hear. And this is me. If you have any more questions, you're welcome to ask me on mail, or usually I'm near the coffee. Thank you very much.